All right, students, let's go ahead and go over this practice test here. Uh, we should remember that cosine of 75, this angle plus this angle are complementary, so they have to add to 90. So 75 plus what is 90? 15 degrees. Do I have it right up here? Yes, I do. Okay. So if I was to look at this, cosine of 75 would be the adjacent over the hypotenuse, so that'd be x over y. Well, what other one also gives me x over y? If I do the 15 degrees, the x over y is the sine opposite over hypotenuse. So the sine of 15, as we have right here, equals the cosine of 75. And so if I type sine 15 in the calculator and cosine of 75 in the calculator, I will get the same answer. Okay, so they're complementary. Number two, you walk 5 miles south and then 8 miles east. 5 miles south, 8 miles east. Okay, so that's a right triangle. And now I'm just doing Pythagorean theorem. A squared plus b squared equals c squared. So you have a 64 plus 25. You take the square root. You get square root of 89. Plug it in your calculator. Approximately 9.4 miles. Number three, in the triangle, C is the right angle. Okay, you have B is 8 and C is 14. So C is 14. B is 8. So that makes that. Solve for A, Pythagorean theorem. Okay, so you have a squared plus 8 squared equals 14 squared. Subtract the 8 squared across. So that's why you see the 196, which is 14 squared minus 64 equals 132. Take the square root of that and simplify that down. 4 goes into 32, so I know 4 will go into 132. So 4 times 33, and square root of 4 is 2. Square root of 33 does not break down. Notice it says exact answer. That means you're not to put it in your calculator. All right, number 4. A, capital A means angle A is 24 degrees. Little c is 13. So that's the side length across from angle C. Find the value of AC. Segment AC. AC is right here, where I put the X. So that's going to be the adjacent side over the hypotenuse. So that's cosine. Cosine of 24 equals X over 13. Cross multiplying, you get X equals approximately, or X equals 13 cosine 24. That'd be the exact answer. That's why I have an equal sign, but it says round to nearest tenth, so that's the approximate symbol, 11.9. You put in the calculator. Do not forget you must be in in degrees. You have to change from radians, which is the default, to degrees. All right, number 5. You have these pieces of information. You should recognize that. It's a Pythagorean triple. It's a 5, 12, 13 Pythagorean triple, just doubled to 10, 24, and 26. Okay, so that's why you see up top here, I've reduced it down, divide each by 2, and you see the 5, 12, 13. So I'm just going to do that now instead of simplifying later. So the sine of A is 5 opposite over hypotenuse. We're talking about A. Okay, so that's going to be 5 13ths. The cosine of A, 12 13ths. And the tangent of A, opposite over adjacent, is 5 12ths. Okay, I'd already reduced those down from 10, 24, and 26 to 5, 12, and 13. Make sure you have your answers reduced, simplified. All right, next we have just labeling the sides as OA and H in reference to angle A. So I have to know angle A is across from little a. So there's angle A. So that means this is the adjacent side. This is the opposite side, and that's the hypotenuse. Hypotenuse never changes. Okay, that's just checking to see that you know, because if you can't do that, you're guessing all the way. All right, number 7 now. We have special right triangles, 30, 60, 90. If C is 30, we know the hypotenuse, as the hypotenuse, we know the 30-degree side is exactly half it. So 15, and this 60-degree side is root 3 times longer, 15 root 3. Notice again, exact values, nothing in your calculator. Number 8, we have two 45, 45, 90s. It says find the value of x given that y is 4. Y is right here, so that's 4. And that's at 45, 45, 90, so that means this is 4 also. And the hypotenuse to be 4 root 2. Well, in this triangle, this is the 45-degree side. So how do I get from the 45-degree side to the hypotenuse? I multiply by root 2. So 4 root 2 times root 2 is 8, because root 2 times root 2 is 2, times 4 is 8. It's randomly generated, so you could have had a 30, 60, 90 and a 45, 45, 90, or two 30, 60, 90s. You have to know how to work both. Number 9 is specifically just a 45, 45, 90, and given that C is 22, remember we set that equal to A root 2, divide by root 2 on both sides, and then rationalize. So I have to multiply by root 2 over root 2, and I get 22 root 2 over 2, which then simplifies down to 11 root 2. And don't forget the shortcut is take your C, divide by 2, and multiply that answer by root 2. And so 22 divided by 2 is 11 times root 2 is 11 root 2. Number 10. If A is 12, A is crossed from the 6-degree side, so I set that equal to A root 3 is 12. Divide by root 3, then rationalize. I get 12 root 3 over 3, and 12 divided by 3 is 4, so A is 4 root 3. That's the 30-degree angle. So a 30-degree angle is actually letter B. So I put that right there. And how do I go from the 30-degree angle to the hypotenuse? I double that. 4 root 3 doubled is 8 root 3. Okay, over here now. Angle TSU is 30. Again, these will be randomly generated. And angle R is 30. Okay. X is 6. So X is across from the 6-degree side. So 6 equals A root 3. Divide by root 3. Rationalize. And I get 6 root 3 over 3, which then simplifies down to 2 root 3. So 2 root 3 is my 30-degree side, as you see right there. I double that to 4 root 3 to get the hypotenuse. And in this triangle, that 4 root 3 is a 30-degree angle. And I'm trying to get the hypotenuse, so I need to double that to get the hypotenuse. That makes it 8 root 3 for my final answer. Okay, it's knowing your 30, 60, 90s. All right, backside here now. Oops. Find the area of the triangle to the nearest hundredth. Okay, I can use the formula A equals 1/2 AB sine theta, or if I don't want to memorize that, I can just draw my right angle. It's my height. Okay, I know the area of a triangle is 1/2 the base times the height. Well, my base, they've already given me, is 6. So I can fill that in. I need to find the height. Since theta is 22 and A is 8. So it's using 22, I'm doing the opposite of the hypotenuse, which is sine. So sine of 22 equals h over 8. Cross multiply, and I get 8 sine 22. So I multiply this by 8 sine 22. And notice that's all what we have right up here as well. 1/2, there's my 6, and there's my 8 sine 22. Okay. So I have 6 is 3 times 8 is 24 sine 22. Put that in a calculator again, it has to be in degrees. And you round to the nearest hundredth and you get 8.99 square units because area. Number 13, find an acute angle. If theta is an acute angle, well, that's between 0 and 90 degrees, which puts it in quadrant 1. So look at that. This is the sine of that theta is 3/5, opposite over hypotenuse. And I should then see it's a 3, 4, 5 Pythagorean triple. Otherwise, I have to use Pythagorean theorem to get that 4. And they want you to find the cosine of that angle now. Cosine is adjacent over hypotenuse. So 4/5 is my answer. Here I have another one. Same idea. It's an acute one. So that's first quadrant again. Theta is always this reference angle here. And the tangent, which is opposite over adjacent, tells me it's 5, 12, so then I should recognize I have a 5, 12, 13 Pythagorean triple. I can fill that in right away, or else I have to use Pythagorean theorem to come up with my 13. And now it wants you to find the sine of theta. Sine of theta, we should know, is opposite over hypotenuse, which is then 5/13. Okay, 15 now. Find the measure of angle A to the nearest tenth, given the following. Little b is 3, so I have to know that that's across from big B, and little c is 10 across from big C. And I want theta, so that's my adjacent over my hypotenuse, which is cosine. So I should have cosine of theta equals 3/10, and I need to get rid of cosine, so I do that by inverse cosine. Whatever you do to one side, you do the other side. So I type this in my calculator, and I get 72.5 rounded to the nearest tenth. All right, 16. Find the measure of angle A to the nearest tenth, given little a is 12 and little c is 17. So now we're talking the opposite over the hypotenuse. So that's sine of theta equals 12/17. Again, I get rid of sine with inverse sine. So I have theta equals inverse sine of 12/17. Put in a calculator and you get 44.9 to the nearest tenth. Okay, 17. Where's 17 and 18? I don't know why I don't have them on the drawing here on this worksheet. Well, there was 16's work. I did it over there. 17 and 18. I don't know what happened to the problem itself, but a 17, I can tell you what the problem is. Once you're doing tangent with the slope, slope is always opposite over adjacent. It's always going to be the tangent, and it's going to be of 39. You just plug in a calculator and you get 0.088097 and there's thousandth, and then depression tells me it's going down. So I put in the negative for depression, negative. Okay, and it must have around the nearest tenth, so 0.8, negative 0.8. 18 had to do with that tree, or your eyes are 1.5 meters above. You're trying to find the height of the whole tree. It goes down to the ground. So it's 1.5 there to where your height of your eyes are. Your angle of elevation, it had to tell you was 63 degrees here then. And you were 20 feet away from the base of the tree. And it wants you to find the total height of the tree, which is h plus the 1.5. So then we have tangent, because it's h and 20, which is opposite over adjacent, which is then tangent of 63 equals h over 20, cross multiply, and h equals 20 tangent 63 plus that 1.5. Put all that in my calculator, and I get 40.8 meters, because it must have told you you were in meters. All right, that goes ahead and explains it. 13 minutes.